This is Module 1, Lesson 2. Here we are looking at evaluating numerical expressions with exponents. Exponents are a shortcut for repeated multiplication. So instead of writing 6 times 6, for example, we would write 6 squared, where 6 is the base and 2 is the exponent. So as another example, if we wish to write using exponential notation 5 times 5 times 5, we would write this as 5 cubed because we are multiplying 3 5s together. If we want to evaluate an exponential expression, such as 7 to the 4th, this would mean we would do 7 times 7 times 7 times 7. I'd multiplied 7 4 times because my exponent is 4. Well, 7 times 7 times 7 times 7 comes out to 2,401. Now, when we're working with exponential notation and we have negative numbers involved, it's important to be very careful about where the negatives are. So in example 3, if I have negative 6 squared, well, the square is only touching that 6, so this means that I have a negative and then 6 is multiplied twice. In other words, I come up with negative 36. On the other hand, in example 4, these parentheses around the negative 3 is telling me that I'm multiplying negative 3 twice. So in this situation, negative 3 times negative 3 is positive 9. So it's important to pay attention to examples like 3 and 4 where the negative is squared or not. Now let's look at evaluating expressions for a given value. So for example, if I have x squared and I'm told x is negative 10, well, I would write that we have negative 10 squared, which comes out to negative 10 times negative 10, which we know is 100. Notice that I put parentheses around the negative 10 when I plugged it in. That's because the original expression said all of x is squared. So I used the parentheses to make sure that everything I put in place of x, the negative and the 10, were squared. So it's always a good idea to use parentheses when you're plugging in a value for a variable. So next, if I have 4x squared when x is 3, well, this is saying I have 4 times 3 times 3. So only that 3, only the x was squared, so this is 4 times 9, which is 36. Now let's look at some rules of exponents using whole numbers. If I have 5 squared times 5 cubed, we can see it as 5 times 5, that's from the 5 squared, and then 5 times 5 times 5 from the 5 cubed. So overall, there are 5 5s being multiplied, which gives me 5 to the 5th. So, when you multiply numbers with the same base, here 5 is the base, you can add the exponents. In other words, we did 5 to the 2 plus 3. We added those exponents together to get 5 to the 5th power. Next, if I have 5 to the 4th divided by 5 cubed, well, that gives me the 5 times 5 times 5 times 5, 4 5s in the numerator, divided by 5 times 5 times 5, 3 5s in the denominator. Well, now I can see I can cancel 1, 2, 3 pairs of 5s, because when I cancel 5 over 5, that's really canceling out a factor of 1. So overall, I'm left with a single 5 in the numerator, in other words 5 to the 1st power, which is just 5. So when you divide numbers with the same base, you actually subtract the exponents. So here we did 5 to the 4 minus 3, which gave us that 5 to the 1st, which was 5. Lastly, if I have 5 squared cubed, well, that's where I'm coming up with 5 squared times 5 squared times 5 squared. I cubed the expression 5 squared. So from our first rule, that is 5 to the 2 plus 2 plus 2. I'm adding the exponents because I was multiplying like bases. So I have 5 to the 6th. Therefore, when we raise a number with an exponent to another exponent, you end up multiplying those exponents. So we did 5 to the 2 to the 3 as 5 to the 2 times 3, which is 5 to the 6th. All right, let's look at a couple examples. We want to evaluate 3 squared divided by 3. Well, in the numerator, that's using the third rule about an exponent to an exponent. So 3 squared, I multiply those exponents, and I have 3 to the 4th divided by a 3. Well, now I'm going to use the second property about dividing like bases. So 3 to the 4th divided by 3, I would subtract those exponents, and I would see that this is 3 to the 3rd. Well, 3 to the 3rd, if I wanted to continue to evaluate, this would be 3 times 3 times 3, which is 27. Lastly, if I'm looking at 3 to the 3rd times 3 to the 8th, this is using the first property about multiplying numbers with like bases. So I would add those exponents and do 3 to the 3 plus 8, which is 3 to the 11th.